Hey everybody. Today we're working with strings in R. I'm going to mostly be working with tidyverse tools here, but there are lots of good options in base R, including functions like grepl and gsub. I've already loaded up tidyverse. You'll see that's given me access to the string R, or stringer package, where these functions are contained. In this vid, I'm going to hit three major topics. First, finding and possibly replacing substrings within character vectors. Secondly, splitting strings into substrings, into pieces basically. Finally, doing the opposite, combining strings from separate pieces into one. At the end of the vid, I'll talk just a tiny bit about regular expressions, regex or regex, but only just a little. Throughout the vid, I'm going to be working with a piece of the sentences vector. This comes with the string R package, which is going to become available with tidyverse when I load tidyverse. It's got something like 700 entries, so just for brevity, I'm going to subset just the first 10 sentences. Things like the birch canoe slid on the smooth planks. Alright, so let's talk about finding and replacing substrings. The first tool I want to show here is string detect, str_detect, which will return a logical vector, trues and falses, determining which elements of the supplied character vector include the specified pattern. So, for instance, string detect sentences, quote on will return true for elements 1 and 6 because we have the string on in 1 and 6. You can see right there. But you don't have an O followed by an N in any of the other words. If you actually want to keep the sentences that have the trues here, where the matching condition is fulfilled, you want string subset. So string subset sentences, quote on is just going to give me those two sentences. Looking at string detect and string subset, you can already see the common syntax that exists throughout the string R package. The string or character vector in question comes first. Basically, that's the thing that you're searching or manipulating. And then after that come the arguments that describe how to search it or how to manipulate it. In this case, we're searching for that particular string. So this is really consistent with the way things are structured through the rest of the tidyverse, where the thing being manipulated comes first. If you want to make substitutions within a string, use string_replace or string_replace_all. The first instance there is just going to replace the first occurrence of the string. The second one here, string replace all, will replace all occurrences. So for instance, string replace sentences, 2, where the first case of 2 is lowercase and the second is uppercase, will look like this. You can see that we've made changes, for instance, to element 2 here, where the word to got capitalized because of this. Obviously, you can tell here that these functions are case sensitive, and that's true throughout the string R package and just in general when you're working with strings. Everything's case sensitive. That's how you want it. String replace all here is going to take every occurrence of the word the and capitalize it, but only, again, if the occurrence of the word the is all lowercase. So let's go ahead and execute that. And you can see, for instance, in line 2 here, in element 2, glue the sheet to the dark blue background. But notice that element 1 here hasn't been changed because the word the, in that case, was capitalized. Now, if all you need to do is mess with capitalization, usually there's a function that's going to do what you want to do. I use the base R functions to lower and to upper if I want to wholesale make everything lowercase or uppercase. And if I need to do more fine-grained changes, for instance, changing to sentence case or title case, I'll use functions from the string R package, things like string to sentence and string to title. Next, let's talk about splitting strings. The fundamental tool here is string split, naturally enough, and that's going to accept first the string or vector of strings that you want to split up, and then the pattern where you want to split it. So typically that's just a single character, for instance, a space, although you can use as many as you want. The output's going to be a list. In this case, you can see a list of length 10. We started with a vector of length 10, so there's going to be one element of the list for each element of the sentences vector. And then the elements of that list, or rather the elements of that list, will be the individual words that are being separated by the sentence, separated by the space. So for instance, that first sentence was the space birch space canoe, etc. Now, if you just have a single string and you don't want this list format, you just want like a character vector back, I would suggest string split 1 rather than string split followed by an unlist. So for instance, string split 1 sentences parenthesis 1 is just going to take that first sentence in the sentences vector. So now we just have a single string. And then with quote, quote, I'm going to break it up with no separator. So it's going to break up that sentence into its individual letters. Let's go ahead and execute that. And you can see we did get that character vector back. It now has one element in that character vector for every letter in the original sentence. To extract words, use the word function. And so this is going to separate words based on a space by default, but you can specify a different separator if you want. The word function accepts only a single string, which makes sense when you think about it. So if you want to apply it to a character vector like sentences, you'll need to use something like lapply, map, or one of the friends of those functions. To illustrate, first, let's apply the word function to just the first sentence in the sentences vector. Let's take the second word there. That's what's being indicated with a start equals 2 here. So as we've seen, the second word in that sentence is birch. The birch canoe, blah, blah, blah. This next line here is going to apply that same operation to every element in that sentence's vector that we're starting with. I'm using map character, but lapply or an sapply would work here too. Starting with the sentence's vector, I'm going to apply the word function with a starting position of 2, starting word of 2. I'm going to do that to every element of the sentence's vector. So you can see the second word in each of those sentences returned as a character vector. Next, let's talk about combining strings. This is a place where I'm still using the base R functions paste and paste0. And that just has to do with the fact that I learned those before I got familiar with the string R package. And I think that's pretty typical, where if you already know the base R functions, you probably don't end up learning the string R functions just because they do more or less the same thing. But if you're coming to strings for the first time or trying to accomplish a task for the first time, a lot of times the tidyverse tools are slightly simpler, slightly more user-friendly, and in some cases faster as well. So if you're learning this for the first time, you might check out string C, string concatenate, which works great. All right, so fundamentally, the paste command is going to take individual strings, paste them together with a space separator. You can see equitable comma equations. When I'm pasting that together, I get equitable space equations. You can pass multiple strings, and you can pass a different separator. So for instance, www.equitableequations.com, like that. Paste0 lets you paste things together with no separator, just sort of by default. It's a shortened version of paste with a sep of just quote, quote. So for instance, I can use paste0 on www.equitableequations.com to get that web address. I often use paste0 when I'm needing to programmatically build web addresses. This is a good way to do that. All right, so this is not a video on regular expressions. I'm not going to attempt to cover them particularly, but I do need to wave my hands at them just a little bit, because you might run into trouble if you try and search for certain characters. So for instance, if I want to determine which elements of the sentence's vector ends with S period, so basically the last letter of the sentence is an S, string detect sentences, comma, quote, S dot, quote, isn't going to work. In this case, we get trues for all 10 of the entries here, even though if you look at sentences, only a few of these end with S period. The first one, the fifth, and I think there's one more, the ninth. The reason here is that some characters have special meanings when we're doing searches, including the dot. And that's generally a good thing. It allows for more flexible searching, but there are some situations where it works against you. And searching for S followed by a period is one of them. So let me start by showing how it is a nice thing with what this chunk that I have here on lines 115 through 117. String subset, sentences, comma, parentheses, sentences, comma, quote, S dot I. So here dot is representing any character at all, and so the thing that's being searched for is an S, any character, and then an I. And in this case we have two of them. We have slid, where we have SLI, and we have here between stockings and is S space I. So this allows us to search for more complex patterns. But if you want to do the simple task of just searching for S and then a period, you have to do a little bit more work. You have to precede that special character with 2 slashes. And this lets R know I want to search for the literal dot. So now when I do string detect like this, I'll just get those 2 sentences that end literally with an S and then a period. Now there's a ton of other stuff that you can do with regular expressions. Again, stay tuned for another vid on that. I'll just show one little thing just to give you a sort of bit of flavor here. If you use brackets, you can allow for multiple options for the match. So what we're seeing here on line 128 is going to allow for either a capital or a lowercase t followed by an H and an E, basically every instance of the word the that might be included in the sentence's vector here. And you can see it's returned 7 of the 10 elements. These are exactly the elements that include the word the. Lastly, just a reminder that this Quarto document that I've been working on throughout this video will be available on my website. You've already seen the address a few times, so if you want to code along with this video, you might check that out.